Hello everyone. Today we are going to learn about microservices and see a live demo using a capital market example, specifically a mutual fund microservice. So by end of this session, you will understand what microservices are and how they interact with databases, APIs, and front end, how to build a how to build and test a microservice using modular architecture. Okay, so we will also do a small activity map features as a microservice to reinforce our learning. Okay, so what is a microservice? So let's start with a simple analogy. So imagine a supermarket. Okay, so in a monolith system, one cashier handle all sections, like example, dairy, bakery, fruits. So if this cashier is busy, all checkout stops, right? So the monolith is mono mean single. So monolith application, one single application handle all the business logic, like our supermarket example. So in a microservice system, each section has its own cache. So dairy section has own cache, bakery section has own cache. So each section works independently, and if one is busy, other continue serving. Okay. So let me show you. Let's draw a diagram, and I'll show you how this is working. So this is first we will understand monolith. Okay, let me text here. Monolith architecture here. So this is our user interface. Okay. So this is going to be single front end app. Okay, so this example. Okay, so application layer. Let's put maybe put it here so that is easy to see. So application layer here. So what does it mean? Application, all business logic in one large module. Okay, module. So next one, we'll go to database layer, right? Keep on building. Data access layer first, and handles, just for our node, handles all database queries. It's not typing. Queries and updates. Okay, the next one, last one, database single shared schema. Okay, so one, so as a B, you don't need to no much detail, but you should be able to capture requirement for microservice related development. Okay, so I'll make it just to be clear. Okay, so this is the UI, user interface. The front end send request to the same uh, backend for all features like login, registration, payment reports, and everything, right? So that application layer, all logics, modules like customer account, accounts, payments, right? So here, users are approaching for the different activities, right? And through the this sent to the application layer, like behind the scene, it's a different module. I'll show you one example, like customer accounts or payments. It's sent to those systems. So it's combined in one code base. So entire thing is combined in one, right? So what's happening inside the database layer? So a single layer handles data queries for entire system. So if the application grows, it it becomes difficult to manage and test this one, right? So the database, only one shared database, all features read and write from a same table. So this is how it's look like a monolith architecture, right? So now let's talk about modular architecture. Okay, so we talk about here monolith we talk about. So let's here we'll enter something modular architecture. Okay, so what is this modular architecture? So modular architecture is a design approach where system is divided into separate modules. Okay, so let me write it. Separate modules. Each response, so each responsible for a particular features, or we can say business function. Okay. Okay, so this is the modular architecture. Like I can give you one example. Think car. Okay, so think car as the whole application. So the engine, brakes, or transmission, and air, so air condition, right? So these all are like separate modules. Right? So each modules can be upgraded or repaired without redesigning the entire car. So that's the benefit, right? In software terms, modular architecture means like each module or service has its own logic, data, and purpose. Modules interact using well-defined interfaces or APIs. One module can change without breaking others. Right? Example, we can have a customer module handle registration login, loan module for processing loan application, payment modules for handle payment transactions, reporting module for generate reports. So each is developed and deployed independently but works together to form the complete system. So what is the benefit of a microservice architecture? Right, so let me introduce here, or maybe I'll introduce a new slide here. Okay, benefits. So let's enter the benefits. Scalability, right? So you can scale only the module that need more resources. Okay, so you can scale only the module that need so that needs more resource. Okay, so independently you have control, faster faster developments, because all API approach. Team can work on different modules on the same time. So in parallel, you can assign one team to work on mutual fund microservice, one team work on monitoring microservice, right? So in parallel, you can work. Easy to maintain also, right? Easy maintenance. So easy menu fix or update one part of without affecting others, right? So here we have team A, team B, parallelly we can talk, right? And also better fault isolation. So let me write that one too. Better fault isolation. So what does it mean? If one module fails, other continue to work, right? So these are the benefits, a main benefit having a microservice architecture, right? So now let's visualize how microservice interact with other component. Okay, so let's go here. Let's include a text here. So microservice architecture. Okay, make it a little bigger. Okay, so let's draw the diagram here. So user interface, and so it can be web or mobile. I'm just taking example. Front end. Okay, so this go through API gateway. So request coming to API gateway and request. Let me put it here so that routes request to the correct microservice. So we have multiple microservice. So as we discussed beginning, like login, we can have a different microservice. In payments, we can have a different microservice. For the mutual fund, we can have a different microservice based on the activity, based on the transactions the product customer is accessing after login. So based on that request, the gateway can route to the appropriate microservice here. Okay, so we can, okay, so maybe I'll include here. So just to show you, we can have different microservice. Okay, hold on. This is easy for me. One more microservice. So let's have two microservice. Oh, so 2 or 3. So based on the product, can have different microservices. Okay, this, let me bring this one, and okay, just to make simplicity, we'll have two only. Okay, because I don't want to spend time modification this one. So let's say this is the customer microservice. Okay, I don't know, service. Okay, so this is fund microservice, and let's assume, or like payment microservice. Okay, I write MS. Okay, now the benefit of this one, each microservice has its own DB database. Okay, so unlike the monolith application, so here we have a customer DB. So here we can draw a separate fund DB. Let's say fund or payment. Okay, so let me make a little smaller. So now you can see in one this one. Okay, so user interface is front end, right? User interact through a single web or mobile app. So the API gateway acts as a single entry point, and it decide which microservice should handle each request, right? So if the transaction or the user activity related customer related, so it should route to the customer service microservice, right? So microservices, each service handle one business function, right? So what's happening while we are isolating? So we will keep the business function related that particular service customer is accessing in that same microservice, right? So example, registration, we might have KYCs, right? How to log in and how this customer should be allowed, what ID types we need, and all kind of business logic we can keep here. So fund microservice, uh, fund, okay, it sounds like fund. Fund microservice, manage mutual fund and product and other stuff, right? Capital market related, we can have the payment microservice, manage process payments and transaction, right? Like credit card and other stuff. So they work independently and communicate through REST APIs, right? So it's communicate to front end or its database to REST APIs. So database per service, each microservice its own database, like you can see here. So changes is one don't affect other, right? So if you want to update something here, it won't affect this one, so this service will work. Okay, so now I will show you a live demo. So this is a microservice I built using Django Python. So just to demonstrate how this concept work. Okay. So first, let me show you the project structure um, so that you will understand how this one. Okay. So here we have funds here, right? So this is the microservice app. So inside here, I have everything, all the setup for the microservice. So here, under the capital service, so this for capital market service, I have all the logics which required for this one, right? Example, the mutual fund and other stuff. Okay, so we can add, like for the customer service, you can add one app here. You can add for login, so you can keep on adding for this one. Okay, so now here let's go to so before I start, you might hear developers are talking Swagger, or like now Open API, right? So it's nothing but Swagger is a tool set for designing or documenting or testing REST API, right? So don't worry, like it's not something. It's very easy. If you have the Swagger URL, you can straight away you can go and try it out. Whether if your Microservice is existing or any other API is deployed. Okay, so let's think this is our Swagger UI. Microservice is deployed, and we are going to try it out. Okay, so here I have a post method. We can post. We have simple for field fund name. We have a fund type, NAV, and the risk level. Okay, so these are the important fields we are going to create a entry in our database. Okay, so let's assume this request coming. This is the admin or some user filling from front end. So this sent through the API. API comes to the microservice. So microservice will take care of this one, insert into the database, or whatever the logic need to do. Processing will be done by the microservice. Okay. So let me quickly show you the database also. So open database, capital market. Okay. So go to browse data, and okay, so this is what we are capturing. This is what we are assuming it's going to come from the front end. Okay, so let's do a quick test here. We can use Postman also, or you can use Swagger. So this is the alternate for the Swagger. We can use this UI. Using this UI, we can post transaction. Okay. 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 So here sample, you can see this is how it's going to be the sample here. So value you can first is fund name, fund type, and the value and the risk level. Okay. Here we can enter. So I'm going to copy the same one just to keep easy. Alpha level fund, and equity you can select okay, debit or hybrid or whatever you like. Okay, so I'll keep hybrid, and let's put 200. There is decimal too. Okay, so risk level, you want to keep low or high? Okay, let's keep it low. Okay, so let's post this one. Okay, I didn't get an error. So I guess it's saying HTTP to one created. Okay, so let's go to our database and let's do a quick look. Okay, so this is the amount let me bring here side by side. You can take a look. Okay, so this is what we submitted, 208, an alpha equity fund and low risk. Okay, so we similar for just the demo purpose, I have post and get only created. So let's do a get request and see what are the records available in the microservice. Okay, I mean in the database. Okay, so you have seen in our database we have five records. You can see all the five records, right? So these activities are happening from front end, right? So customer or admin, some user are accessing, they're clicking some button. So behind the scene microservice, the request is sent to the get request is sent to the microservice, our mutual fund microservice, and mutual fund microservice, it will fetch from its database and send this request to in the response in the API. So API will communicate. So you saw our diagram, right? So API will communicate. So example, this. So request is coming here. So API will gateway is route to the correct microservice. Microservice fetch from the database, retrieve from the database, and send back in the response. Okay. So this is what happening behind the scene. So we can test this one from Postman also, right? So we can test our microservice API. We can test from Postman also. So let's do a quick testing in Postman also. Okay. So I have already created the request here. So first we are going to do a post here. Okay, so same request only. So this is a post method we covered under API discussion. This is a post method. Fund name, we can type alpha 123. Okay, so equity, we will leave the fund time equity. So this time we'll post 300. Okay, and let's leave it high. Okay, so we can send a request. So it's saying ID number 6 and alpha 123 is created. Okay, very easy, right? So let me refresh this one. So we can see our mutual fund entry is created in the database. Okay, so we have a get method also. We can retrieve this one. Okay, so there is nothing in the body. Okay, so it's listing everything. So which is the ID number 6, our. Okay, so very easy. So when you are capturing requirement, you can get this information. You can include in your user story. Okay, so these are 6 entries we have here, and these are the 6 entries you see. Okay, so now let's write user story. How do you write user story for this one? Okay, so we will kind of we are doing a reverse engineering. So this is the end result what we supposed to build. I show you first. Okay, so now let's go back here in Jira, or like let me see if I have the case study here. Okay, we did this one. Okay, I need a blank page here for the case study. Sorry, I forgot to include that slide. So our case study is, sorry, the business requirement or case study. So what we need to build here, a capital market company or bank, whatever. Okay, assume company wants to manage mutual funds efficiently. Okay, and currently fund data is stored is something similar. Okay, stored in um, spreadsheets, causing errors and delays, of course, right? Delays. Okay, so the company wants a microservice. So they're not telling directly they need a microservice. Business won't tell you we need a microservice. Okay, so this is just for your understanding. I'm writing this one. So there are so many typo errors. Okay, let's correct it. Okay. So what are the feature we need, right? So first one, you see we need a post method, right? So fund creation. That's what we need, fund creation. And let's assume listing only, right? Fund listing, which is the viewing. These are the two we need. And we need updating the net asset value, right? So easy to integrate with other applications. So NAV, NAV stand for net asset value. Okay, so here we are not capturing for update. I just include this might be the case business one, right? So creation, get, and update, right? So these are the things. Okay. So let's draw flowchart for this one quickly. However, because always when you get a requirement, try to create a process map or diagram, so which is easy to test with, easy to explain to your technical team or engineering team. Okay, that's what we are going to do. Let me check how big is this one. Okay, so let me increase the size so that you can see. Okay, so this is our new feature. So customer or user or anyone you can, okay, whatever the company initiates action, whatever action initiate the action. So what, this is not for the customer, okay? So this is for our internal team to explain our requirement, okay? So API request. So let's assume this the front end user is doing the activities like creation or listing, clicking those buttons. So the API request is coming, and so this is our mutual fund microservice. Okay, and what are the features we need here? Okay, let me list here. Okay, create fund and list fund. Only two we are including. So usually we need to provide update also. Okay, so let's say first MVP, first iteration, we have only create and list only. Okay, and we can give all four methods, right? So list, update, and delete. Okay, so let's assume we only have this requirement. Okay, so the next one, this is the business logic we captured in what functionality business needs. These are the functionality business is looking. So this is our database layer. So from here, so we have same. Okay, so we can put the arrow here. Request is coming. When the request is success, and we have to, Microservice will send the response to the API. API will communicate to the front end, so the customer see the result. Okay, so very straightforward, right? Very simple. So now let's go back to Jira and create our user story. So what we'll write, manage mutual funds via API, or create new microservice to manage mutual fund. So usually this is not one story, okay? So you have to set up the skeleton, the structure of the microservice that can be a separate development task. So we are only focusing on the functionality, right? So you can this is not an easy task. This will take at least 1 or 2 sprint setting up the microservice, right? So setting the microservice structure, so that you have to create a developer task or user story. So once you create it and there is no API or there is no service associated, from using Swagger, you can just go and try it out if the microservice is existing, which is when you ping the health check of microservice, you'll get okay 200 response, right? So we are only focusing the functionality piece of the microservice this demo, okay? Just to let you know, if you are wondering, like maybe you will think very easy to create a microservice, so that's wrong. So that's the project going to take 1 or 2 months based on the business requirement. Just for the demo purpose, I'm explaining the this is only the one functionality, okay? So let's write the user story. Sorry, user story as a capital market admin or user, okay, anyone. I want to create an view, only view, okay? So you can add, let's say you are adding all 4 functionalities here, you can add update or delete or something, okay? So we are only keeping whatever our requirement is, okay? Update mutual funds, okay, mutual funds via a microservice, okay? So this is, you are writing the requirement as a business analyst, okay? Business won't tell you they need a microservice, okay? They will tell we want to digitalize, that's it. So that I can accurate what fund information and integrate with other. We can learn integration tomorrow efficiently, okay? So other services efficiently, okay? That's a user story. I think via acceptance criteria. Okay, so what do you need here? Let's insert bullets here. Admin, you can write given when then also, but I will just write the straight point. Admin create a new fund. So here are the columns we want to give, right? So this button, so fund name, fund type, NAV, and the risk level, right? So this is what Paris or Jira story here. So you can list one by one here. New fund, I'll include here just for fund type, and value and risk level. Okay, so second one, admin or API consumer can list all via get request. So you can create separate user stories for post method separate user story, get for separate user story. So I'm just including everything so you can because so that different developers can work on different user story, but keep it that way, that is clean and multiple people can work and more efficient also. Okay, or if one developer is going to work, this can be done during one sprint. So you can create two user story, but I'll include everything here. Level admin can update, not update, so admin can list. So we are not giving update feature here, right? So only two here enough. Admin cannot delete. So maybe we can write all data is stored in the database, because why we are saying so that persists across sessions. So if you write this one, so that tester can validate this one also, right? What are the API content? So you can capture here also, right? So maybe should I include here? Should I include here? So API returns proper HTTP. You can write all the status code what's expected. So what we see 201 created, right? Just go here. So 201, this is 200 for listing. So when you created one test, so 201 created, right? So one is created. Go back to the Jira, right? We are here. So 201 created. I think 200 for okay listing, right? And error code, if server error and other stuff you can include, you can talk to your developer. Okay, so I think this is good. Let me save this one. So now how do you explain for the estimation, right? Grooming. So let's assume this is the user story. You need to groom. Do you have a place to update the so okay, thank God we have this one here. Okay, so during the product backlog refinement PBR, okay, so you can first discuss what is the purpose of this microservice creation, and there will be dependencies database creation. Um, there will be some other dependencies setting the project structure of the microservice, right? So health check, establishment of health check, and after do all the groundwork, framework setup is ready, and we are taking these user stories, right? Let's assume all our microservice structure is already existing. We are trying to add endpoint to our microservice. Okay, so that's all about this user story. So so for this one, I would say it's not very difficult once we have everything. So I would say 5 story point but if you are going to do the two service here itself, so you can go with 8. Okay, so we have get and post together here, so we'll go with 8. Okay, so that's a summary of our case study. Now time to check your knowledge. Okay, so the first question, we have 10 MCQs. Let's go through quickly. The first question, what is a microservice? So I will not read all the options, so let's only discuss the answer. Okay, so a small independent module of an application, right? So microservices are self-contained modules, each responsible for specific business capabilities, right? So question number 2, which of the following is a benefit of a microservices? Right answer is independent development and deployment, right? So microservice allows team to develop and deploy and scale modules independently. Question number 3, how do microservices typically communicate, right? So via REST APIs or messaging queues. So today we only saw APIs only, so there other system input JMS listener can have messaging queues also, right? So Microsoft using well-defined interfaces using API or messaging systems. Okay. Question number 4, which scenario represent monolith system? So mono means single, always remember. This the example we discussed, right? One cache handler checkout for the entire store. Question number 5, which of the following is true about microservices and databases? Microservices may have their own database or share one, right? So each microservice can manage its data independently for modularity and fault isolation. Okay. Question number 6, this is related to the project we did. Okay. So in Django, what is a good way to structure a microservice? So create separate apps for each service module, right? I show you during the demo. Question number 7, which of these is not a typical microservice characteristics, right? Tight coupling with other services, right? Microservices are loosely coupled, enabling independent development and scaling. So that's the key feature of a microservice. What is the main advantage of microservices over monolith architecture, right? So microservices allow independent scaling and maintenance. Microservices are improve flexibility, maintainability, and fault isolation compared to monolith. That's what we discussed the feature, right? So which tool is commonly used to document and test microservice API? So I mentioned this one uh, during this one. So Swagger is the right answer here. Okay. Um, I don't have the Swagger version, otherwise I could have. So you just go to Google. So I'll show you. This is how it looks like. This is free version, I guess. So I don't have anything to show, but just want to show you the interface. This is the company I'm talking. So Swagger provide interactive API documentation, making it easy explore and test microservices. Okay, that's what I want to show you. So last question. In a microservice-based supermarket analogy, what represents a microservice? Separate cashier for dairy and bakery and fruit. So you won't forget it. So that's why I include this example. Okay. So now time for our interview questions. So there are Multiple type of interview question can be asked during the interview. So let's discuss quick interview questions. What is a microservice? So you can prepare something like this. A microservice is a small independent module of an application that handles specific business function, right? So you can talk about some benefits like develop and deploy scale independently. Example, whatever the application you are working. So e-commerce system, payment, e-commerce website, Microsoft handle payment system, another handle the inventory, right? That's one example. So how do microservices communicate with each other? So you have seen, right? So using APIs, microservice communicate through REST APIs, right, or messaging systems. Each service exposes endpoint that other service can call. What is the difference between monolith and microservice architecture? So this can be asked always. Remember our one cashier and multiple cashier example, right? So all functionalities are in a single application. Changes to one part may affect others. Scaling requires scaling entire system. Microservice functionality is divided into independent service, modular approach. So each service can deploy, developed, and scale separately. The question number 4 is related this one. So what are the benefits of using microservice, right? So we talk about independent development, deployment, is whatever we discuss is the same answer. Okay, so I'll bypass this one. What are the common challenges when using microservices, right? So I would not say challenges, but it's good to know always. Okay, so distributed system complexity, right? Requiring handling service communication, retries, mechanism, and failures, right? Because there are dependency services, we need to take care of this one, databases, and if data enrichments are happening or like need to communicate to another database, right? So if system not available, it cannot be processed. So it will store the data in a retry table, and we need to implement some mechanism to retry the failed records to process again, right? So those are kind of things. Data consistency, each service may have its own database, right? Make across service complex, right? So it's that one. Monitoring and debugging, this very important. Need centralized logging and monitoring tools, right? So we need to create example. If your microservice deployed in Anthos, right? So we need to create monitoring, alerting, dashboards to see which service are failing, how many transactions are going, and we need to analyze logs. So many things to do here. So deployment and management. Managing multiple services increase DevOps complexity, right? So let's talk about some structured questions using STAR method. Describe a situation where you worked with microservices. So this is a straightforward question, right? So in my previous project, our e-commerce or whatever your project, platform was struggling with scalability because it was monolith application. Okay, so the old legacy applications, this might be the case. So now all the companies are building microservice architecture or like moving functionality from monolith to a microservice. Okay, so you can, if you have worked on any application, you can include. Otherwise, the example we talk about, this is more than enough to answer the question. Okay, so I need help break the system into similar smaller independent service to improve maintainability and performance. I identified core business functions. So you don't need to worry like how this can be implemented, right? So your main job starts with capturing the business requirement. What business need? Business need, okay, application, it's need to update or create or delete or view something, right? So that's where you independent. So where this request is coming from front end, so there might be a API involved, right? So there we go. if there are any other services needed, right? So the solution architect, the tech lead will come up with the design and say, okay, um, we have to implement a new microservice. So your business functionality requirement won't change. So this is architectural change, architectural implementation. But as a business analyst, you should know what approach they take. Based on that, you have to create user stories, right? So that's why, but this won't affect anything to business for sure. This will be faster service, performance improved, data integrity, and everything. But when you're capturing requirement, so main focus, maybe you think this a lot of work, so many technical thing you need to know. No, your job is just to capture business requirement, and you can get into more deeper about how the solution will be implemented during the design phase. Okay, so we are here. Functionality. I design API for communication services. So you are not designing API. So you are containers for deployment. So your captured requirement. That's what I meant to say. After implementing Microsoft, each module could be deployed independently. So these are, you have to convert it into like business analyst perspective, right? We created two APIs, right? The user story, first creation, second one list, right? So you can include those. How did you ensure communication between microservices? A microservice need exchange data for order processing. I need to design a reliable way to microservice to communicate, right? So here I captured, right? Not design, I captured requirement for so and so task. So we test here, not you implemented, right? So we implemented as a team. So here you are saying always use capture requirement, okay? Gather requirement, okay? REST API for synchronous communication and messaging queue for an event. Also include error handling and retries and reliability. Unfortunately, time is not enough. I cannot show you error handling use case here, so we just discussed the happy path only. Okay, so maybe another video I'll talk about the edge cases and the error handling in a microservice or the API. Okay, resulted service communicated seamlessly, order were processed without failures, and system became more resilient service without to the service downtime. Right. So describe a challenge you faced while implementing microservice. During deployment, one microservice was failing intermittently, so causing cascading errors. So my goal was to identify the issue and prevent it from affecting other services. So these are topics you need to ask, like when you are writing your requirement. Otherwise, um, your tech lead will tell you. So this can cause some technical debts in your system. So these are should be captured during requirement gathering. Okay. So I analyzed log and added to centralized monitoring, implemented circuit breakers. So these are kind of development perspective you're talking about. So that's why what kind of question can be asked, right? Maybe focus on the first five question I showed you, but definitely the requirement gathering phases, like your job is gather this first question is applicable for you, right? Gather the business requirement and talk to your technical team, and they will tell you like how many APIs, how many endpoints read, how many microservices we are going to create for different project. So that's where your start is. But you should know these are can be asked. These are the uh, possible questions. Okay, so these are kind of technical side questions. Last question: explain a time when Microsoft improved process. Right. So as a business analyst, your job is to make sure is there any performance requirement? Is there any authentication requirement? Right. So you need to ask your write checklist, your requirement gathering questions, so that you have to include in the user story, then only the tester can test this one, right? So our monolith inventory system was slow update stock information. I had to improve the speed, reliability, inventory update, right? So I designed an inventory microservice that handles stock updates independently, exposing the API for other services like order, payment. Okay, so we are talking about more specifically about the use case. Okay. All right, so you can include these things in your resume also, like example, the example what we learn here. So we learn capital market microservice, right? Um, so this is just an example, okay? So this you can list your microservice here, whatever your experience, what technology you use, right? It's like you're not coding, so requirement gathering side, okay? Um, Design a mutual fund microservice. So here you are writing gathered requirement, right? So maybe you help write test cases and you test through the Postman or Swagger. Those you can include it here, okay? And LinkedIn update build. So here it's a build microservice. So you didn't build a microservice. So you gather requirement for microservice project. Sorry, this one. Okay. Okay. I think we're right up the time. Let me check my PPT if I miss anything. Okay. Uh, okay. I think we cover everything what related microservice today. So this is the front end. Just want to see if I don't miss anything. Okay. So this is the summary. My, you learn what is a microservice, what's the difference between monolith and microservice approach, why we need a microservice, what are the key features like is to scale and update and maintain, right? And you show the demo and we build a user story, right? So what is coming next tomorrow? Vendor integration, right? So learn how external systems are incorporated, like integrating with microservice. Okay, so until we see you next time, thank you very much, everyone. Have a great day.